Hello everyone. This is my project submission for the Emertxe internship. In this video, I'll share what I learned, walk through my smart home automation project, and show a live demo. From code to connection, I learned C fundamentals, built embedded systems, and explored IoT innovation. Core C concepts included data types, number systems, control flow, arrays, and operators. Functions and pointers helped me write modular and memory-efficient programs. I explored storage classes and preprocessor directives to structure my code better. C++ object-oriented programming taught me classes, objects, inheritance, and polymorphism for clean and reusable code. Using Arduino, I connected sensors and actuators and tested safely with PICSimLab. Through Blynk IoT, I learned how to control and monitor devices from anywhere. Finally, I combined everything to build complete embedded IoT systems, from coding to simulation. Smart home automation. My project is called Smart Home Automation, controlling and monitoring home devices using Arduino and the Blynk app. Project overview. It automates temperature, water level, and lighting using sensors and relays. The Arduino reads data, sends it to Blynk Cloud, and performs automatic actions. Hardware architecture. The setup includes temperature, water, and LDR sensors connected to the Arduino. Ethernet handles Blynk Cloud communication, and Serial connects to PICSimLab for simulation. Automation logic. The heater turns off automatically at 35 degrees Celsius. The inlet valve fills water below 2000 units. And the garden light reacts to daylight using the LDR. System testing and demo. I validated everything in PICSimLab and Arduino IDE. Data displays on the LCD and Blynk app, ensuring both local and remote control. Project demo. After uploading the hex file, the simulation starts. Here you can see the Ethernet module. It connects Arduino to the Blynk IoT cloud. This LCD shows live temperature and water level readings. The LDR sensor controls the garden light. When it gets dark, the light turns on. Right now, the water level is below 2000, so the inlet valve turns on automatically to fill the tank. Next, I'll turn on the heater. You can see the temperature gradually increasing. When the temperature reaches 35 degrees Celsius, the heater automatically turns off, confirming the control logic works. Then I switch on the cooler, the fan activates, and you can see the temperature dropping on the LCD. Finally, I open the outlet valve. The water level decreases, showing that volume control also works properly. Blynk App Demo. On the Blynk mobile app, I created data streams for all components and linked them with virtual pins. I have buttons for the heater, cooler, inlet and outlet valves, and gauges for temperature and water volume. When I press any button, the signal goes through Ethernet to the Arduino, and the device responds instantly. The app gauges update in real time, showing live feedback for temperature and water level. This allows me to control and monitor the system completely from my phone. Code explanation. Now, I'll quickly show the main Arduino code that powers the entire system. In main.h, I defined all the Blynk pin macros. This makes it easy to manage components. In ldr.cpp, I initialized the garden light pin and created a function to control its brightness automatically. In serialtank.cpp, the volume function reads the water level, and there are functions to enable or disable the inlet and outlet valves. In temperaturesystem.cpp, I set up heater and cooler pins and used a function to read sensor temperature. Finally, in the main.ino file, all modules are combined. At the top, I've given the title and short description. Next, you can see the Blynk template ID, template name, and authentication token. The token connects my Arduino board to the Blynk cloud. After that, I've included all the required libraries. SPI and Ethernet are used for communication between Arduino and the internet. Blynk Simple Ethernet handles the cloud connection. Wire and liquid crystal I2C are for the LCD display. Next, I've created an LCD object with address 0x27 and size 16 by 2. This display shows the live data, like temperature, water volume, and the status of each system, such as heater, cooler, and valves. Then, Blynk Timer is used to update readings repeatedly. For example, the temperature and volume data are sent to the app every 1 second automatically. Now let's look at the Blynk Write functions. When I press the cooler button on the app, the cooler turns on and the LCD shows cooler on. If I press again, it turns off, and the LCD shows cooler off. The same happens for the heater. When I press the heater button, it turns on, and the LCD displays heater on. The function update temperature reading is used to send temperature and water level data to the Blynk app. This function runs every 1 second through the timer. The handle temperature function checks the value of the sensor. If the temperature is higher than 35 and the heater is on, it turns the heater off automatically. The handle tank function does a similar job for the tank, ensuring the inlet turns on if water is low. Now in the setup section, I initialize all modules one by one. The LDR module, the temperature system, the serial tank, and finally connect to the Blynk cloud using the authentication token. Then I start the LCD. It displays home automation for a short time, showing that the setup is done correctly. The timer is also started here to schedule the regular updates of data. Now let's come to the loop section. First, Blynk Run keeps the connection alive between the Arduino and the app. Then Timer Run triggers periodic functions like data updates. The brightness control function checks the LDR value and adjusts the garden light automatically. Next, I read the temperature and water volume values. Everything is displayed on the LCD for live feedback. Finally, this main file brings all modules together, LDR control, temperature system, and serial tank, into a single smart home automation system. It runs smoothly with Blynk Cloud and gives full real-time monitoring and control from the mobile app. Conclusion. So that was my smart home automation project, designed, coded, and simulated as part of the Emertxe internship. It connects embedded C, IoT, and real-time systems together, truly from code to connection. Thank you for watching and for your time and interest.